Thank you very much. Thank you very much for bothering to turn up and being here, especially those that travelled. That's everyone except me. Oh, and you've come across that a little bit further than me. This is somewhat different to our main exhibition in San Francisco, which for those of us here that can attend is on the 29th to the 1st of May next year at the Observation Post at the Presidio. Thanks for being here. I think it's quite important that people that have got an idea to using unmanned aircraft for conservation purposes get together, talk about what they might do, like to do, what fails, what works, what doesn't work, all that sort of thing. So, here we go. It is going to work. One of the things that really annoys me is people think this is today's technology. They think it's happened in the last 5 years and how great all this is. It's not. This is the Kettering bug. It was designed in 1918. It was just as you can see, that's like me flying. It arrived just too late for the end of the First World War. It was made by the David Wright Company. They made 50 of them, and they stockpiled them. Could fly 120 kilometres at 80 kilometres an hour. Basically, very like the V1 rocket that became in the Second World War. Pointing in a direction, 120 k's away, power goes off, wings break off, comes a torpedo, and it goes. So that's this is test footage from 1919. We're not doing anything new by a long, long way.
But how is it controlled?
Yes, Sperry whole autopilot. It's the Sperry autopilot, the first one in there. So obviously things have moved on a little bit. Actually, got rid of the sound on that. Two Gulf Wars, smartphones in particular, produced mass-produced sensors, and high-capacity, low-weight batteries, and miniaturized video systems that made the sort of systems we all know and love possible. Civilian open source autopilots now exceed capability of several military systems, not only price but also feature. Wars are really good at accelerating innovation, but it can't really be hundreds of geeks and veterans around the world that build and crash and build again and create data and revisions far faster than a well-built DoD vendor can possibly manage. Why am I showing this image? Well, you're probably aware that the Canadian Lancaster is flying across to Europe and is flying along the Royal Air Force One, and that's allowed them to have an unusual flight. These two aircraft types were designed by exactly the same team. The Lancaster first flew on the 9th of January 1941. The Vulcan, the jet, had its first flight on the 30th of August 1952, just 11 years later. So only 11 years in technology separating those two aircraft, which is, I think, is quite extraordinary. So think where we are now with unmanned aircraft and think where we're going to be in 10 years' time.
Sorry, is that an unmanned one day?
No, that's the two Lancasters. Two Lancasters and the Vulcan. No, so just 11 years separate those designs, which is amazing. Now, I had a telephone call from Victor Hugo, a man on Trackham, a driver of full-size aeroplanes and, more importantly, model aeroplanes. He contacted me for help with an autopilot setup, and at this point, I'm going to thank Victor for letting me play his gang and his gang with his gang, and let me tag along. It's been no end of fun, and he's very inspiring and a fantastic chap to work with. It was a really amazing time filling around with it. Maybe people don't say that. But he told me about a year-long trial undertaken by UKZN involving wildcats and jackal, led by researchers Ramesh and Bruce, who would like to help. I was very excited at the prospect of disappearing off somewhere super exotic in Africa and doing great things. And I discovered it was right here, right around this park, right over there, presumably in the Tower Midlands. So it's turned out really to be a blessing in disguise, as I was able to try out different ways of flying to hear collars and keep an eye on the hardware deployed. And very kindly, Vic brought some along with him. So the animals wear the collars, I think everyone here knows this, that record position, ambient temperature and movement, and they speak to a base station. We've got one down on the floor there. And that's by UHF, and they say what they've seen since the last time they spoke. It's a line of sight link, and the base stations are connected to the web, if you will, via a cell phone link. If the animal moves away from the base station over a hill, the data is stored on the collar until the next time it sees the base station. When looking for animals with an RPAS, I can make the base station text me every hour if it's heard something. So every hour it tells us it's heard this, that, and the other. So we know at least something's happened. It takes an hour or so. So I thought it'd be a good idea to create our own airplane, and it would be very clever, get CNC also with it, and do all these clever things that you think you can do, and the reality of it, of course, really was that China won it and I did. At the time, the Super Sky Surfer had come out, so almost ready to fly, 2.4 metre wingspan, basically a huge pixel. And there I've got a Ruby U there, autopilot, very, very impressed with that autopilot. And the pixel and autopilot going at 2.5. And now you can buy the Super Sky Surfer with an autopilot in it, an APM clone, for less than $500, ready to go, which is just quite extraordinary. The commercial off-the-shelf airframes can only go so far, and eventually we're going to have to build our own platform, that's for sure. Unmanned aircraft is said to be used for dull, dangerous and dirty tasks, and flying and listening to collars is most certainly in the dull category. You just basically launch and fly circles in the sky, in this example. I'm flying for an hour looking for a particular animal that was living off to the left and consistently living off to the left. So before the study started, I planned, we put the base station, one base station in a great place that could see an awful long way. Those of those up at Shutties, up at the shuttle was leaving. And the red on that map represents where the base station could easily see radio-wise or here. And to start with, I flew in places where I wouldn't. So the orange area there, that was unit number 10, and that lived, well, you can see here, it lived over this little ridge there, it lived over there. So the little arm, we needed to go and fly there. But we soon got to know where they were living, and it became much, much easier to find them and track them with the aircraft were required. I've flown 175 flights in total in support of this tracking project. One of the great things for it is that you can look over the hills. Animals are caught in two groups and two areas in order to see difference in pattern of life. These areas are far enough apart to require two base stations. One served in particular, kept in an area over the hill from the main base station, and this animal was perhaps the most successful as far as the RPAS was concerned for gathering data. I was able to drive to a spot and overlook where the cat was and provide the link over the hill. So that's obviously, he was tending to live over here and over there, and that shuttle was where the base station was the ridge there. So that was that flight we showed there, just a couple of orbits, just provided the real. We found that we could reliably talk back to a base station that was well sighted. So as long as the base station had a good view of the surrounds from a distance of 10 kilometres. So if you put yourself out 10 k's and then your aeroplane's looking at further 10 k's forward, you've extended that range 10 kilometres. And as we know that around here, a lot of the valleys is almost in fingers, so you can look down into those valleys a lot better than just a fixed sight. So that was very useful. Well, in reality, and there was, very sadly, that probably the most important use for the aircraft was to find collars where the animal had been snared. We had at least 3 that we used the aircraft to find them. All I would do is go, because you build up data, you get in position before 72 hours, so eventually you have a rough idea of where they're living, so then you don't fly in that area a lot. And it was here when we went to see this one, was a particularly grim one. The fence line that it was on was absolutely covered in snares. All the snares, for those that don't know, were positioned on animal paths, going into wetlands and soft targets. And where this one was, can't really see it, but that was a serval and that was a jackal about 2 metres away from where I was. So there was 2 animals snared in the same area. And the only way to find that was the aircraft.
So the accuracy was unbelievable. I mean, amazing. The colours said there was no activity, and we went 2 meters forward. Oh.
Yeah. Yeah, that was a particularly grim scene. We've had another one where the collar was very cleanly cut off with a knife. That was way up somewhere. And another one where a bit of fence line had recently been refurbished, and there was brand new snares all going all there, and new fence with maybe that the new wire. And unfortunately, when these things weather, they're terrible, really hard to find. But that's the sad reality of this. How far? Well, one of the jackals really excited us by walking to Escort to start with. Came up from where it was called, went up to Escort, went home. We all thought, wow, that's amazing, that's fantastic. It's gone about 30 kilometres. And then it disappeared, and it reappeared 21 days later, and it reappeared up here, very close to Harrismith. It was picked up at a base station. We rushed up with the aeroplane, and again, it was a lovely day out of experiences with the mission go. We've got a couple of things, and it's now living happily up near Kestel, about 160 kilometres away from where it was supposed to go. And I think I'm right in saying this is the first time this sort of travel has ever been logged and this behaviour has ever been shown. So it's even the other jackals that were caught, even they were tending to go at least 5 kilometres a day. They go quite a long way every day, just doing their own thing, which is, I don't think researchers thought that's what was happening. It does raise, the interesting point it raises is that most flights that we're doing for this happen in unprepared areas because you've got to arrive at the field and you've just got to go. And that requires a degree of ability in manual flight modes because you might be landing in a track between trees or whatever to get into small spaces. Well, that's a trained operator, but probably best to always operate from a large prepared area and fly to the area of interest. We can't always do that. The future, well, we've had a lot of fun playing with these collars, and we started experimenting with other ways of mapping and finding out where collars are. And this shows signal strength mapped against position. Vic hid some legacy collars, some legacy pinging collars at his place, and we drove around and we looked for them within a laptop running some software. Hopefully we'll get it embedded and flying soon. So these are the hidden collars, and this is signalling along the railways operating on a similar frequency. So that's pretty exciting. And some of the data collars, the bigger collars that are sending data position reports by UHF back, also have VHF. They also have this both. Yeah, so that's got both VHF and UHF report. And if we can roughly map where the VHF collar is just from flying over it or driving around, it gives us a better idea of where to go to look for the UHF collar. That one opens up correct me if I'm wrong, every 9 minutes to talk. So if you're flying and you're not in the right part of the valley and you're not in the right place in that 9 minutes, it's not going to talk to your aircraft. So for the so that's quite, I think that's quite exciting, showing some promise.
Now the VHF gives us every 1.5 seconds.
Yeah.
Which is to pick up. So use the VHF to actually pinpoint where the VHF is.
So I can bring it all the way back around to the military thing. I started the military thing in 1918 and the military doing. What the military do is, because in some ways wildlife is fighting a war, and the military employs signals intelligence, or what we call SIGINT, and they listen out to what people are radiating. Your car radiates all sorts of noise when you're driving along, electrical noise. Boats, airplanes, everything generates electrical noise. And they listen out for that, and then they start mapping that electrical noise to know perhaps what's there in the battlefield. So it's not just speech. And right now, we are, and I can say we are actually able to listen and repeat the UHF data collars, as you've seen in the last slide. We're able to map legacy collars, can map Wi-Fi transmissions, and I can map cell phones. So I think we need to, everyone's rushing out to go and look for owls and look for stuff. There's other things that we can map that will contribute to a bigger picture of what's happening again. Every RPAS flight should gather as much data as it can and make its flight count. So that's me. Thank you very much.
Gary, you can tell me a little bit more about the balloon stuff then. We can also tie into that.
The balloon stuff, well...
And also going up to some condo, that was quite interesting.
The ritual?
Some condo when we went through for the rhinos.
I thought it was secret. Well, yeah, we went, as Vic said, we went looking for rhinos, and I think the trouble is when you're deploying this college, or when you're, remember I'm speaking out to, it's one thing to make stuff handed to people that they deploy out to the field, and off they go there. If you don't go to where they've deployed it, you don't see the terrain that they're in, and you don't see where they've sited their base stations, especially their base stations, then you don't realise perhaps why their projects aren't going to look so well. We went out to places with some rhino. We did sort of find some stuff, but my word, we drove not physically very far. Everyone here works in the reserves, but it took us all day to go about 8 kilometres, and an aircraft could have been over that and back home again in time for 2 hours and 10 minutes. You know. So we've got to nail down where they're finding things better, and be conscious that both sides can use this technology as well, which is a little bit of a worry. But yeah, that was exciting. So that's me. I think I would very much like to hand over now to Tim Snow. Really well.